Hi guys, so today's lesson is basically a review of things that we've already talked about this year. Yay for transformations, your favorite thing. But once again, the biggest thing that you need to remember is that vertical goes on the outside and that horizontal is with the x. And then horizontal also lies somehow, right? So if you're taking a look at a horizontal translation, if you're going to the right, it's actually subtraction. If you're going to the left, it's actually addition. When it comes to a vertical translation, you're just putting that transformation on the outside of my original function, so x cubed. And on the outside at the end, you're putting that transformation. For a vertical stretch or compression, once again, you're putting that transformation on the outside of the function. I like to think about this with parentheses. So I have my function f of x and the a goes on the outside. So here I have my function x cubed, the 6 goes on the outside. Same thing with the compression by a half. I have my function x cubed and I'm putting the half on the outside. That's different with a horizontal stretch or compression. So notice how if we're stretching by 5, it flips and it goes in the parentheses, excuse me, with the x. And then once again, a vertical reflection, so that would be over the x-axis, is on the outside, and then a horizontal reflection goes on the inside with the x. Once again, these rules you're just going to have to memorize, and there's not really much else to discuss about that, right? So it says if we have this function, f of x is equal to x cubed minus 6, this is f in the blue, and then g is what they want you to write. So g of x, all we did was move, see how that y-intercept moved down too? So I'm going to take my function f of x and I'm going to subtract 2 on the outside, but now I actually know what f of x was. So I have my function, and on the outside I subtract 2, so my final function for g of x is going to be x cubed minus 8. The next example here, we start with our function f of x equals x cubed minus 6. If you look at that y-intercept, I'm actually moving 1, 2, 3 to the left to get to g of x. And if you recall, this is saying I'm going to take my function f, and then with the x, so horizontally, I'm going to move to the left 3. And if we're thinking x's are liars, the parentheses are liars, left 3 is actually going to be a positive 3. So even though you're at negative 3, it's lying to you, and it's going to be positive. So if I look at my function, usually I have an x cubed minus 6. But with horizontal transformations, what you're going to do is you're going to replace the x with what you have in the parentheses here, so x plus 3. And that will give me g of x. So once again, left is a horizontal transformation, which means it has to go in the parentheses with x, and you're going to replace x with x plus 3 because you are translating left 3. So next up it says let f of x equal x cubed plus 5x squared minus 8x plus 1. Write a function g that performs each transformation. So if you are reflecting across the x-axis, that would mean that any sort of function is, so if I have a U-shaped graph, if I reflect across the x, it's going to open down instead of up, which means it's vertical, which means it needs to go on the outside of my function. And remember, reflection means you need to add a negative in somewhere, right? So what I'm going to do is take my f of x, and on the outside of that function, I'm going to put a negative. So if I were to actually do that, I have my f of x. I know it's x cubed plus 5x squared minus 8x plus 1. And on the outside of that function, I have to apply the negative, which means I need to actually distribute that to get g of x. That is different than when we reflect across the y-axis. That would be a horizontal transformation, which means it goes with the x. So if I have my function f of x, that means with the x, this time I'm going to put the negative. And if I look at my function, that means every time you see an x, you're going to replace it with a negative x. And a lot of you are going to say, well, doesn't that make it be the same thing? Well, no, not really. Negative x cubed would become a negative and then x cubed, but negative x squared would become positive. So we'd still have a positive 5x squared. Negative times a negative is a positive 8x, and then I'd get plus 1. And that will be my new function, g of x. Right? So we've talked about translations. We've talked about reflections. The next thing that we are going to talk about are stretches and compressions. And this stuff is a little bit tricky, but once again, my advice to you is pick out some key points from your function f. And then you should be able to see where those points go here. So if you look, these points look like they're getting closer to the x-axis. Oops. Sorry, guys. ImageMate decided to quit on me. Let's start over. Okay, so if you look at these points, they look like they're getting closer to the x-axis, which means they're going in the vertical direction somehow. And since they're getting closer, that would be a compression. And it looks like the number 3.5 is maybe 1 3/4. So I would say it's getting cut in half. That distance is getting maybe cut in half. So what we have to do with our function, it's got to go on the outside because it's vertical. We're going to have to multiply by that scale factor 1/2. And if we were to actually write that in our function rule, right? So I would take my function, 2x to the 4th minus 6x squared plus 1. I'm taking that function, and on the outside, I'm going to multiply by 1/2. So for my g of x, I should get just 1x to the 4th minus 3x squared plus 1/2. And technology fails me again, so let's try one more time. All right. So this first example, once again, we were moving closer to the x-axis, so vertical. This time we're taking those same points, but you're going to notice they're moving away from the y-axis, which means it's moving horizontally. And since it's getting farther away, this is a horizontal stretch. And then if we are multiplying, it looks like we were at like 1 1/3 and it's going all the way to 4. So we might be multiplying by 3, which means what we're actually going to have to do is flip it and multiply x by 1/3. So our function rule, since x's are liars, we need to flip that scale factor to make it 1/3. If I were to apply this rule, I would have 1/3 x every time I see an x. And then I could write my g of x function. And for the sake of time, I'm not going to simplify that. I'll just leave it like it is. What the hey? Let's just do it. 3 to the 4th power, that's 81. So I would get 2 over 81 x to the 4th minus 1/3 squared is 1/9 times -6 would be -6 over 9, which would become -2/3 x squared and then plus 1. So once again, g of x is equal to 2 over 81 x to the 4th minus 2/3 x squared plus 1. Okay. If we're looking at this next example, we have f. You can look, I like to identify my critical points here and then see where they ended up. So here I have a 4 and then it goes all the way to 1 and it looks like we're moving vertically. So for g, it looks like we had a vertical compression since we were getting closer, right? Should spell compression correctly. By In this case, we're getting cut in 1/4. Remember, with vertical, we don't have to do any flipping. So that's all I would have to write. And then let's practice a few more of these just with words. So it says write function f in each of the following ways. So first thing that we're going to do is compress vertically by a factor of 1/3. So we're going to take our f and multiply the whole thing by 1/3. So 1/3 of 6x cubed minus 3 gives me 2x cubed minus 3. And then once I have this, 2 units to the right means I have to go x minus 2 because x is liar. So this means only the x is getting replaced with x minus 2, but we're going to use this new function here and replace that x with x minus 2. And then I have my g of x. The only reason I did not simplify this is because I would have to expand using Pascal's triangle, and that would take a long time. So let's not do that. Okay, another two-stepper. The first thing we have to do is reflect across the y-axis. That would be a horizontal reflection. So only the x is going to become negative. So if I had 6x cubed, it would be 6 times negative x cubed minus 3. This function is now what you're going to use to shift 2 units down. So if you do that, up and down is vertical, so on the outside you're going to subtract 2. And when I have that, I'd have 6 times negative x cubed minus 3, and then a minus 2 on the outside, and then you can combine like terms to get your g of x equals 6 times negative x cubed minus 5. And then, last but not least, transforming functions. This last one, we have f of x is 8x cubed minus 2, and if we're compressing vertically by a factor of 1/2, vertical's on the outside, so we're going to multiply that by 1/2. And when we do that, we should get 4x cubed minus 1. And then the next thing we have to do, it says move the x-intercept 3 units to the right. So if we're doing 3 units to the right, we're going to replace x with x minus 3. And when we do that, we should get g of x equals 4 times x minus 3 cubed minus 1. Beautiful. All right, transformations. Let me know if you have questions. Once again, same rules that we used before. We're just kind of reviewing them. So if this video moved fast, you can go ahead and look back at some of the other transformation videos from previous chapters. All right, good luck.